And here we go with video 3.2, solving inequalities. Yesterday we worked on graphing them on a number line. Here we're taking it one step further, so get your notebooks ready. Here we go. So rules you need to remember and follow when solving inequality. There's just one very, very important rule, and it's in purple right here. So first, inequalities are solved just like equations, but there's one important rule to keep in mind. This word should not be here. That's a typo. Everything's mathematical. We don't need to restate that. If you multiply or divide both sides by a negative number when isolating the variable, the sign changes direction. So the inequality sign will flip. If you look here, you have the inequality negative 2x is less than 6. To isolate x, we need to divide by negative 2 and get rid of it. So we're dividing both sides right here by negative 2. As you can see, we have an answer of x is greater than negative 3, but our original inequality was less than. So that just means that our inequality sign flipped directions. When you divide or multiply both sides by a negative number, you have to change the direction of the inequality sign. So let's do a basic how do we solve inequalities with addition or subtraction. So these are your steps for solving all inequalities, much like your steps for solving equations, except for this graph on the number line part, and we still have to check, of course, when we solve inequalities or equations. So the first thing you do is isolate the variable. Well, much like an equation, I'm just going to get x by itself by adding 4 to both sides. So I add 4, negative 4 plus 4 is 0. We're left with x is greater than 11. I don't need to change the direction of the side. All I did was add 4 to both sides. Even if I subtracted and put a negative number on the other side, I still would not have to change the direction of the sign. It's only when I am multiplying or dividing that I have to change that direction. So we get our answer of x is greater than 11. So I'm going to draw myself a number line. And I'm going to just start at like 9, 10, 11, 12, 13, 14. I'm going to graph it on the number line. I'm going to put an open circle at 11 because it is just greater than, not greater than or equal to, so 11 is not included in the solution, and I'm just going to shade everything greater than 11. Remember that the sign points in the direction that you need to shade, so I need to shade in this direction. And now the third step is to just check your work with a value in the shaded region. So let's pick 12. That's in the shaded region. So I'm just going to plug in 12 for x. So 12 minus 4 is greater than 7. 12 minus 4 is 8. Is 8 greater than 7? That's true. So we know we solved correctly and we graphed correctly. Now we have solving inequalities, multiplication, and division. Same exact process as solving equations with multiplication, and division. So I have n over 5 in my first example. I know I'm going to have to multiply 5 by both sides to get rid of that 5 in the denominator. I'm multiplying by a positive, so no signs are flipping, and we have n is less than or equal to negative 5. So I will draw my number line. We'll start at negative 7, negative 6, negative 5, negative 4. And I'm going to put a closed circle on negative 5 because 5 is included in the solution. And I will shade everything less than negative 5. And I'm just going to go ahead and check. I did that correctly. Let's plug in a negative 6. So negative 6 divided by 5 is less than or equal to negative 1. That's true because this is farther down on the number line than negative 1. If this was negative 1, this would be negative 2, and negative 6 over 5 will be right about there. So we did it correctly. Let's check out our next example, number 2. I'm going to divide by -3 on both sides, and here we go. We're dividing by a negative, so I need to flip this greater than or equal to sign to a less than or equal to sign. So y is less than or equal to -6. And let's graph that on a number line. Let's do the same thing. Let's do -7, -6, -5, -4. I'm going to graph a closed circle because it's or equal to. And I will shade everything below -6 because everything less than, remember, your signs point in the direction that you need to shade. And the sign flipped, let's just check out why that makes it correct. If we were to choose -7 and plug it in, we have -3 times -7 is greater than or equal to 18. -3 times -7 is 21, and 21 is indeed greater than 18. Let's see if we were to plug in something like -4. If we weren't to flip the sign, if we forgot that, we would see that we did something wrong because we get -3 times -4, and that should be greater than or equal to 18. And 12 is not greater than or equal to 18. So you know if you forget to flip the sign when you do your check, it'll save you from answering the question wrong. And your hot question, I need you to put in your answer, what is the solution to the inequality -4h minus 1 equals 7? This is one step further than what we did in the lesson, but you're all very smart people, so I know you'll be able to do it. Just tell me what h is greater than, less than, or equal to. And the answer to your hot question, we'll practice this tomorrow in class.